The molecule we have here is 3-methyl tetrahydrofuran. The molecular formula is C5H10O. We can see the 5 carbons here, 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 and here. The oxygen's right here at the top in red, and we can only see 3 hydrogens here. But because carbon likes to make 4 bonds, we know that there's most likely 2 hydrogens here, here, and here, and 1 right here to make 10. There's 1 degree of unsaturation, and that comes from the ring here. Degrees of unsaturation could also come from pi bonds, but as we see, there are none. There are, however, 15 sigma or single bonds. This molecule contains an ether. An ether is an oxygen connected to 2 other elements. We can see that in this case, it's an oxygen and 2 carbons. It has a boiling point at 89 degrees Celsius, and it's a liquid at room temperature. There are 5 unique carbons, so each of the carbons in this molecule are unique. This can be determined by looking at what each carbon is attached to. For example, this carbon here is the only carbon attached to 3 hydrogens. This one is the only one with only 1 hydrogen. This one is different from all the other ones because it has attached to a carbon with 2 hydrogens as well as this carbon with only 1. These 2 may look like they'd be the same, but this one is different because it connects to an oxygen and this carbon with only 1 hydrogen. This one does not. Because each carbon has at least 1 hydrogen and each carbon is unique, we also have 5 unique sets of hydrogen. We can see the ratio is 3, 2, 2, 2, and 1. There are 2 lone pairs. Those lone pairs are located on the oxygen. That's because those 2 pairs are not in any bond. All of the carbons have an sp3 hybridization. We know that they have an sp3 hybridization because, again, there are no pi bonds, and each carbon is connected to at least another carbon or a hydrogen. We have 1 CH3, which is most clearly seen right here. We have 3 CH2, which again are these 3 right here, and 1 CH located here. There are no carbon atoms with nothing. There are no carbons with no hydrogens in this molecule.
All right, so in order to make 3-methyl tetrahydrofuran, what I'm first going to do is I'm going to start with this oxygen, and then I'm going to connect it to these first 2 carbons. Then I'm just going to take these 2 and complete the ring, which is where that 1 degree of unsaturation will come from. Then we just attach this carbon to make that little methyl group that attaches to the end of it. And then we're just going to attach these hydrogens to all of the carbons. So you can see that this carbon here has 3 hydrogens attached because it's only attached to this 1 carbon. All of these 3 carbons here are going to have 2 hydrogens attached. And this one here is only going to have room for 1 more hydrogen. So, as I stated, this is where the 1 degree of unsaturation comes from, is because of this ring. And this here oxygen connected to these 2 carbons makes this an ether. And the lone pairs, the 2 lone pairs that this has, is also from this oxygen, because you can see that it's only attached to these 2 carbons and there's no other hydrogens here.